This is a basic arithmetic video on scientific notation. Let's have a look at a few key examples here. To write 3,482 in scientific notation, we must remember that in scientific notation we want to create a number between 1 and 10 for the front bit of our scientific notation. So we want this number to be between 1 and 10. Now the way to do that is to put the decimal point straight after the first non-zero digit. So when you've got 3482, if you put the decimal point straight after the first non-zero digit, it'll go between the 3 and the 4 there. Now in a whole number, the decimal point used to be at the end there. We could have thought of 3,482 as 3,482.000 if we wanted to. So invisibly there's a decimal point at the moment in our original question at the end of the number. And so to move it so that it's over here just after the 3, we will have moved it how many jumps? We will have moved that 3 jumps there. So to compensate for the fact that we've moved that decimal point 3 jumps, we multiply it by 1,000. But 1,000, I'm here to tell you, is 10 to the 3. So we've moved that. We had to move the decimal point 3 jumps across there, and so we indicate that by having a 3 on top of our power there, and that's scientific notation. We've got a number between 1 and 10 at the front times 10 to the power of something. So 3.482 times 10 to the 3. This one we certainly also want to have our decimal point after the first non-zero digit. So we will want the decimal point to be here instead of over here, and once again we'll have to move that 3 places, but we've moved it differently. So what happens here, we'll have 5.4 out the front, and our answer is times 10 to the minus 3. Now the 3 still indicates the fact that we've moved the decimal point 3 places to where we want it, but any number that starts off with a 0 point start to it ends up with a negative on the power in the scientific notation bit. So if you start off with this really small number, 0 point type number, you'll have a negative on your indice when you put it into scientific notation. Okay, going the other direction here, we have 7.2 times 10 to the 5, and I'll just do it that way for a reason. If we're multiplying something by 10 to the 5, we're really multiplying it by 1 with 5 zeros, and we're moving the decimal point 5 places. Now multiplying something by 100,000 will make it bigger, so we'll be moving that decimal point so that the number gets bigger. 1, 2, 3, 4, 5 places, and if we fill up those places that just have loops there with zeros, we'll get a final answer there. That should make sense. Instead of our decimal point being between our 7 and 2, we've moved it across there and we've put some zeros in as well. We'll end up with 720,000 as our answer when we write 7.2 times 10 to the 5 out as a whole number. So what did we do? We moved the decimal point from between the 7 and the 2. We moved it 5 jumps to the right, and if we needed to, we fill in any jumps, any gaps there with zeros, and create a whole number that way. And this one, you'll remember me saying that scientific notations with a negative, they start off with 0 point type numbers. So we're going to be moving this decimal point to the left instead. How many jumps? Well, we're going to be moving it 4 jumps, because you can see the 4 on the indice there. So 3.78 to start with, but we're going to be moving it 4 jumps to the left, this decimal point. 1, 2, 3, 4. Now that's where the decimal point goes. So let's be careful about where we have to put zeros here. We need a 0 at the front just to make sure it looks like a decimal. We need to fill in any of those jumps there that don't have any digits with zeros to make it look like a normal number. And that ends up being our final decimal of 0.0000378. And you'll remember that it's those naught point numbers that are associated with the negative indices in scientific notation. So that being negative kind of indicates we should go 4 jumps to the left to make the number smaller from where the decimal point is at the moment. Alright, so that's some scientific notation examples to help you, one of each type there. All the best, peterblakemaths.com.